Braden Goddard, thank you so much for having me at VCU, Virginia Commonwealth University. You are the non-pro security guy here, huh?
Yeah, pretty much. I'm the main one. We have Dr. Soupy helps out some with pyro processing safeguards and non-proliferation. But as far as security and radiation measurements and all that fun stuff, that's me.
Awesome. Well, I'd love to get into it and what your core specialty is. But before we do, I would love to hear about how you became interested in nuclear energy to begin with.
Yeah, nuclear engineering. It's kind of a weird story. So I was originally a math major, and I said I like math. And my brother was a math major, my older brother. And once you get to the higher level math, it becomes more proofs. And I wasn't interested in that. So I said, I want something that's applied mathematics, solving real world problems. And then I saw physics, and I said, that is way too hard. Let's go with something easier like engineering. And then I didn't want to be just a common engineer. I wanted some specialty, something unique.
Yeah.
And what's more unique than nuclear? So I picked nuclear engineering. And
what year was that? What year did you decide on choose your studies?
What year did I decide to focus?
Yeah.
Well, this starts to date me, but it'd be probably 2000, 2003, 2002.
And that was when the industry kind of had a dearth of nuclear engineers at the time, right? That was a low point for people studying the space?
Yes. Some of the people I knew, some of my friends were saying, some family, this is kind of a dead-end field, don't do it.
Wow.
Some others said, no, there's going to be this giant revival and you're going to be,
prime.
The cutting forefront. And
But do you remember what you were thinking? So it's special, right? But was there anything in particular that just convinced you to join?
No, I just wanted something kind of unique, applied mathematics.
That's cool.
To be honest, I probably did what most people do, and that's not spend enough time deciding, what you want to do in your life, where you want to go for school. You just Google nuclear engineering schools, and the first one that pops up, you click apply, and then you call it good.
That's what I did too. Not for nuclear, but for mechanical. Yeah.
So I think.
And you went to Texas A&M. That was Texas A&M.
Yes.
Which was it's just been historically one of the larger programs out there.
Yes. When I went there, it was the largest, although large, there's different ways to measure it. So I grew up in Southern California. And so we have Berkeley. I looked at it, but I wanted something that was definitely more nuclear engineering. And when I Googled it at that time, it was a lot of chemistry and physics courses. And then I saw Texas A&M had 2 nuclear reactors, which one of them wasn't running really, but that's okay. They did have 2. And so I said, okay, 2 nuclear reactors, and the courses you take are actually, are listed as nuclear courses.
Cool.
So I applied, 1 application, no other schools, said, I'm so awesome, I'll surely get in. I've been
classic engineer.
I've been lucky a lot of my life.
Yeah.
Yeah.
And so you did your bachelor's, master's, and your PhD there.
Yeah.
You just love Texas.
I'm kind of inbred, yes. So they say, don't do that if you want to be an academic.
Okay, so what was your thinking?
So one of the more successful professors in their department is Dr. Charlton, and he got all his degrees. And he's very inbred too. But, so in a way I said, this is maybe a false narrative that we're taught, that you need to go to different schools.
Yeah, especially the nuclear community is so inbred anyway across all the schools. It's like the same thing.
I would say that you should go to the school for graduate school that does the best in what you want to research.
Yeah.
And so for my PhD, I wanted to do nuclear non-proliferation.
Why? What drew you to that specifically?
So I did a master's in more nuclear materials. And I'm sure nuclear materials is great, but it just didn't resonate with me.
Okay.
So I said, no, I don't wake up every morning want to doing this work. And then the work I was doing was on the fuel cycle and measuring some things, and a branch of it had more to do with radiation measurements and material accountancy. And so I started to like that. So my classmates were taking these, non-proliferation courses, learning who has nuclear weapons, how to use them, how not to use them, how to, different aspects of that whole world. And so that started to really interest me. So I did a shift. After I finished up all my master's work, I said, thank you, but I'm going to switch advisors if that's okay.
Yeah.
And
they were cool with that.
Yeah. You should go with what you're passionate about. And if your student's not passionate for your work, it's a disservice to everyone to try to keep you there.
So, so you switch into non-proliferation, which for anyone recently joining in our audience and doesn't know what that is, that means essentially like making sure that nuclear stuff doesn't become nuclear weapons stuff, right?
Yeah. So I think of it as proliferation is to spread something. And so it's stopping the spread of basically nuclear weapons and nuclear weapons technology.
And so what became the specific focus within that space of your research at that point?
Specific focus is on safeguards. So using radiation measurement. Well, safeguards has many aspects, but mine was using neutron measurements to account for all the materials. So someone gives you a can and says, trust me, there's a kilogram of plutonium in it. How do you actually measure it and verify that they're telling the truth?
How do you measure it and verify that they're telling the truth?
So, plutonium spontaneously emits neutrons and emits gamma radiation. And so you measure those radiation signatures and then quantify them.
Are there other methods as well, or is that the primary way you do it?
There are other methods. They all have their advantages and disadvantages. So a lot of times, if you really want a good job, use a combination of different things. Like radioactive decay emits heat, so you can measure the amount of heat that comes off. But of course, other things emit heat, other things emit gamma radiation, other things emit neutrons. So you kind of use like a combination of all of them together to say, okay, it matches with all these different signatures. It's probably what they say.
And what device is used to do this? Is it kind of like a speed gun that the cops might have? You point it at a canister and count the neutrons?
So for gamma rays, in a way, yes. It's usually bigger and more expensive. But yeah, essentially some kind of device that we put up next to it. For neutrons, we want a higher efficiency. And so radiation's emitted isotropically.
What does that mean, isotropically?
Isotropically means in all directions. So you then want to encase the material you're measuring in a detector.
To get the total magnitude and make sure you're not leaving anything out.
Yes. And especially when you're trying to, so when you have a fission event, it releases multiple neutrons. Being able to measure all of those neutrons at once, or as many as you can, helps a lot with the statistical uncertainty.
But it can't be easy to put something in a case, like a giant case, right? Depending on where you are and how big the thing is.
So that is one problem we have is a lot of our neutron detectors are basically wells. It looks like a well. Detectors all the way around and a hole in the center that you put your material in.
And when these things are emitting neutrons, is it safe to be around them? Or are there so many neutrons it's like, oh, stay away?
It's safe. I don't know if I'd want to go to sleep with a kilogram of plutonium under my pillow. But, when you're handling it with a measurement, you wear a radiation badge too, just to assess how much dose you're getting.
Now, okay, so you're saying that plutonium has spontaneous fission events, like uranium-238 also has spontaneous fission events?
Yes.
Does plutonium-239 have a different amount than plutonium-240?
Yes.
And are you able to calculate the ratio between the two using these detectors?
So generally the approach we use is neutrons will tell you an effective amount of plutonium-240, saying if it was all plutonium-240, this is the mass that would be there.
Got it.
So it gives you like a quantification on mass.
Is there any way to derive that ratio without doing some sort of chemical or whatever? I don't know.
You could do, we use gamma rays. And so each isotope of plutonium emits a different energy.
Oh.
And so by using the ratios of those energies, or the number of counts of that particular energy, you can then get a relative concentration.
Cool.
But the gamma rays from the center of the material won't penetrate. They're low energy, and things that are high Z like to attenuate gamma rays. And plutonium is pretty high Z.
Yeah.
It has a pretty high
When you
atomic
say,
number.
exactly. I was going to make you break that out. High Z means atomic number, which is like the density.
94, I believe it is. So 94 electrons it has.
So what form does plutonium usually exist? So I imagine, so plutonium is like made within a reactor as part of the normal process. You know, you shove a neutron on the end of a uranium, you get to a plutonium one way or another. So
keep on tacking on neutrons.
Yeah. So does that mean that almost all plutonium that we have is in the form of a spent fuel rod that has just been tacking on neutrons?
I would say the majority of the plutonium in the world is trapped within used fuel.
And where is the minority trapped?
So there are places that you would want to recycle the fuel because that minimizes the amount of radioactive waste you have, and you can reuse the fuel, right? I mean, we say recycle your aluminum cans, recycle your nuclear fuel.
I like that.
During that process, a lot of times they'll separate plutonium out as its own element.
Got it.
And so then that leaves this window where you say, well, you have plutonium by itself as some probably oxide form or whatever. If you really wanted to, you might be able to take that material and convert it into a weapon if you have enough expertise.
Now, in order to make plutonium a weapon, this comes back to that ratio. The ratio of plutonium-240 has to be sufficiently minimized, right?
Yeah. So it's an interesting conversation.
Yeah, let's hear about it.
So I think the U.S. government back in the day detonated a weapon that they said was with reactor-grade plutonium, and it went boom. So they say you can do it with reactor-grade plutonium.
What's reactor-grade plutonium? What ratio
so it's
is
the
that?
ratio.
Yeah, what ratio is that?
Oh man, you're making me remember specific numbers off the top of my head.
Do it. Or give me an estimate at least.
Estimate. So like I would say weapons grade is maybe 5% plutonium-240, and all the rest is plutonium-239.
Okay.
And reactor grade would then be higher, 10, 20, 30, whatever. It depends on burnup, which we'll define later.
Yeah. And do calculations validate that rather than just trusting the security agencies within the government who say, listen, you can do it with reactors, so now we're so important that we need to be involved in every reactor across the world? Like, if you were to experimentally on a piece of paper try to model, hey, what is the enrichment ratio that you need, does that support what the government said?
Yeah. So basically you're asking,
how much are people angling for their jobs?
Yeah.
Because I see that all the time.
So here's the problem, is in order to figure out, how bad of the plutonium, how much towards reactor grade and away from weapons grade do you have to go before it's not really so functional, basically means you have to know how to design a nuclear weapon. And that is not really out in the open literature. I've seen some papers that do probably more than they should in that direction.
Yeah.
But I've personally, we do some work and we get close and say, well, we're not going to talk about the actual weapon design, but, see, this number's really high, so it probably wouldn't work.
Right.
And I've had some people show up and say, that's great, don't go the next step. You're
from NNSA or something?
Yeah, from the U.S. government.
Yeah, they'll show up.
Just saying, don't
cool
do the next step, please.
Yeah.
And so we don't, of course. But
yeah.
So the exact amount, it depends on your weapon design, depends on your technology level. So it's not really well defined.
But that sucks, because in order for reactor designers to design something to be non-proliferant, it would be nice for them to have a target where the government could at least say, listen, as long as the plutonium coming out of your reactor is 30% plutonium-240, you're cool with us.
So there is a value that it's okay, and that's 80% plutonium-238. And the main reason we have that value is because an RTG, or a radiothermal generator,
right,
basically something that produces heat, and you use that heat to then make electricity.
Yeah.
So what, some spacecraft use that, maybe lighthouses way back in the day.
Yeah.
Where you can't get long-term electricity to them. That type of plutonium is excluded from safeguards because they said that's so crazy you'll never make a weapon with it.
Yeah.
But that 80% threshold, as far as I can tell, based on
that's useless because most of what's in there is uranium-238, which means you're climbing up to plutonium-239, right?
Yeah, basically to make that type of plutonium, you take neptunium targets and irradiate it.
Right.
So you'll never get a plutonium like that out of a nuclear reactor.
Right.
And so we tried to find an exact paper that says, why is it that value 80%? And I think the main thing is if you irradiate a neptunium target, you would never be less than 80%.
Okay.
So it's not really a threshold of what you can't.
Yeah. It's not so useful in reactors.
Yeah. As a weapon, it's more, you'll never, doing the neptunium route, you'll never go below that.
Yeah.
There are various assessments that come up that try to quantify how useful a certain plutonium is for a weapon, but a lot of those are just based on rule of thumbs and kind of hand wavy. A lot of my work, we're trying to quantify it more, saying, look, here's the heat that's produced by these plutoniums, do heat transfer calculations, and show that the high explosives on the outside of this hypothetical nuclear weapon
wouldn't survive.
They would detonate or melt, or there would be internal stresses where materials then crack or deform. And then if your nuclear weapon is deformed, it's not a nice sphere or whatever shape you want it to be, it's not going to have the same yield.
Yeah. And it seems to me like the same could be said for a quote-unquote enrichment of plutonium. Because there's this heat and radiation aspect, you can't use your traditional uranium enrichment centrifugal processes, because if you try to do that with plutonium, it would probably be breaking the centrifuges, right? Because of the high radiation, right?
I think there are definite challenges that would occur if you tried to enrich plutonium.
This is why all the governments designed these channel type reactors that you could do in situ fueling, such that you could shove some uranium in there and then pull it out real quick while you still had a good ratio of plutonium-239 to plutonium-240.
Yes.
Because there was no process to enrich it, really.
And I believe there is currently no process to enrich it.
Good to know.
I'm sure there's people looking at it, but it's not commercialized yet. And hopefully
will never be.
Will never be.
Yes.
Hopefully. Yes.
Yeah. You had an interesting experience in the UAE.
Yes. So after I went from Texas A&M, I went out to the Nevada National Security Site, did some work there. And I said, I really like academia. I want to find a way to get back to academia. And I had a colleague that I knew who was in the UAE at Khalifa University in their nuclear engineering department. He said, we need a postdoc, and we need someone with expertise in radiation measurement from a good university. And then I had known him, so he knows the quality of my work. So he said, apply. I can't promise you we'll hire you, but we'll probably hire you. So I said, okay, it's a postdoc. I like faculty positions better than postdocs, but it's in a foreign country. So I get to gain all the experience of living in a foreign country.
And what's it like out there?
It is different than the United States.
Okay. Different how?
There are definitely advantages and disadvantages. So the main advantage is they have a much better work-life balance. So my child was born out there. So I have a daughter, and she was born out there. And my boss said, okay, you need to be with your wife who's recovering. You need to be with your child. This is an important time. Don't come back to work until you feel like you're ready to come back.
Oh, that's nice.
Yeah. So I asked him, okay, is this like a week or 2 weeks, a month? And he said, no, it's when you feel you're ready.
Wow.
So I do not see too many U.S. employers telling their employee whenever you're ready, you can come back to work.
Yeah. So that's probably because there's a lot of extra money sloshing around out there to make up for it. Like employers here are so cutthroat with their money. It's like, get back to work.
Yes. And so it's like taking time off from work there is not a big deal.
Yeah.
Anything family always comes before work. You have Ramadan where you have reduced hours of work.
Are you allowed to drink out there? Is it legal or not legal?
In the UAE, yes. You need a liquor license, which is not hard.
Wait, the person needs a liquor license or the establishment needs a liquor license?
The person does.
A person needs a liquor license? I've never heard of this before.
Yes. It's not expensive. It's, I think, less than $100. You fill out an application, you apply for it.
Wow. What's the thought behind that?
I think the thought is if you are Muslim, you're not supposed to be drinking.
Okay, so it's just so Americans are allowed to drink.
Well, anyone who's not Muslim.
Right.
So when you enter the country, they ask you, what religion are you? And so you can check, whatever, Christian, non-denominational, not religious, whatever religion you are or want to claim you are, I guess, you can check. And so when you apply for your liquor license, I'm sure they will look and say, you declared as a religion that you're not supposed to be drinking, so then they'll deny you the license.
Fascinating.
Which I guess you shouldn't be drinking, right? If that's what your faith tells you to.
Well, none of us really should be drinking, but it's so much fun.
So you get a liquor license, and then there are certain places you can buy liquor and drink in your house, or you can drink at hotels. Hotels are considered very Western places. You can wear much less modest clothing there, so more revealing clothing. And as long as you're in a hotel, that's considered an okay spot.
And where do you live?
Where did
you live when you were out there?
Just in the city of Abu Dhabi.
Cool. Like in an apartment or something?
Yeah. So in an apartment in a giant skyscraper.
Cool.
Yeah. So it was actually kind of a nice period because the work-life balance was good. Had a new child. The place I lived was quite small. It was only one bedroom, but it was basically a resort. We had 3 swimming pools, a bunch of gyms. We were way up high, overlooked the whole city.
This wasn't like the Burj Khalifa tower, was it?
No. But there are lots of towers that are very tall and nice there.
It's hot there, right? Everyone's got to live indoors, essentially.
Yes. During most months, it's extremely hot and dusty. So all pretty much parking is covered.
Oh, and how do you get around? You drive from building to building, or?
Yeah, pretty much.
There's no underground tunnel network or something? So
they like to have residential skyscrapers connected to malls. And so from where I was, I could walk to a mall all indoors. And it was basically this tunnel that went across the road. And then I can do all my grocery shopping, drink coffee, restaurants, whatever I wanted to. Cool. Without ever having to go outside into the heat and dust.
Sorry to keep talking about this, but I love to explore different cultures, and I actually haven't really met anyone who's lived in the UAE before. But did they talk about climate change out there, and are they worried that it's going to get so hot that the problems that they've got right now are just going to be multiplied even further?
Yeah, that's a good question. So it's really interesting. So only 20% of the population or so is Emiratis. The other 80% is all foreigners.
What are they doing there?
The foreigners are basically workforce. There's just not enough Emiratis to do every single job. So if you need, scientific expertise like myself, they just only have a few people that have, PhDs in nuclear engineering. And even they only got it very recently. So they're building nuclear reactors. They need to staff up the human capital. And they just have had virtually none in nuclear engineering. So they have to hire foreigners to then teach the locals.
And 80% of people in the country fall into the category of foreigners coming in to fill some sort of role.
Yes. I think by percentage, the most of them are laborers. So people who do, build buildings, clean windows, sweep streets, very manual labor.
And so how does this tie back to then the future of the country and their prospects?
Yes. So I don't talk to a whole lot of Emiratis because there's just not a whole lot of them there. But the ones I do talk to, I'll ask them, questions about global politics and things like that, global issues. And they basically say, look, we don't have to worry about those types of things because, we have, the sheikh, our leaders, and they make very good decisions. So we don't have to make these tough decisions. And, I was out there during the last presidential election or the lead up to it. And so there's lots of talk about, politics and voting, and they don't vote out there. They don't, not a democracy. And so, but they said it's good because can you imagine if it was a democracy and everyone voted and you ended up with a terrible leader? They don't want that kind of pressure. They would rather someone else pick a really good leader so they don't have the pressure of trying to decide who is good and who is bad.
Does that kind of attitude carry through every part of life? Like, are they... so like they brought in a lot of scientific researchers and stuff. The people who are born Emiratis, are they more in kind of like a sit back and let the wealth accrue, and just take it easy, or are they ambitious and trying to also get highly skilled scientific jobs?
And you're asking me questions I'm going to get in trouble if I answer. But I will answer. It's a combination of both. So if you're born Emirati, you're fairly well set. You'll live a comfortable life, regardless of how ambitious you are. The ones that seem to be more ambitious, based on my limited experience in academia, were women. And so they're pretty good, especially for that region, with gender equality.
Cool.
But there are still some social things that, like if you're a woman and you graduate high school, then there's going to be a lot of pressure from your family to get married and do stuff like that. One, I don't want to say excuse, but one way of saying, no, I'm not going to get married now is to go to college and say, look, I need to focus on my studies. And then once you get your bachelor's, then you get your master's and your PhD. And then by the time you're a doctor, you have enough say so that you can tell your family, I maybe want to make my own decisions in my life. And if you don't want to get married. So education and moving up, and I guess your corporate ladder is one way to gain more independence. And so if you're female and you want more independence, that's one way to do it. And I saw that definitely with students' grades. Women were pretty much one whole grade level above the men.
You mean in terms of academic performance?
Yes.
That's awesome. Kicking ass over there, yeah. So, all right. So you're teaching out there. What made you decide to come back?
So the position I had was not a permanent position. So it eventually ran out. So I wasn't going to get paid anymore. But also, so having lots of free time and enjoying life is great, but everyone else is also doing that, which means productivity is less. So in the United States, we don't have a whole lot of vacations, so we work a lot of hours, but I think that allows us to do more.
Yeah. So
you'll get trapped out there in a way. The number of journal papers you publish is not as much as if you were in the US, because it's not just you doing less work. All your colleagues are doing less work. So just everyone's net number of publications is less.
Yeah. That was driving you crazy?
If I was out there long enough, it would be a hindrance. And you get to the point where if you apply for a job, say back in the US, your resume is just not competitive compared to other people. There's also a diminishing return when you're in a new environment. So the first little bit, you're learning lots about different cultures, different ways, all that. And then the longer you're there, the less new things you learn.
Yeah. So you were ready to come back into the American culture.
Yes. American culture or a different culture and learn new things.
Yeah.
So there was a couple different paths that could happen in my life at that time.
So what did you take?
So I wanted to go to academia, and Virginia Commonwealth University gave me an offer. So I said, okay, let's try it out.
Yeah.
So far, so good.
That's awesome. Yeah. How long have you been here for?
I've been here now 3 years.
Cool. So you come in, you've got this interest and experience. And now you want to bring this type of education to the next generation of students. What are some of the things you focus on in your teachings?
So one of the challenges we have in teaching any STEM is going from high school to college. The rigor of high school perhaps is not what it used to be.
Why is that?
So I'm not an expert in this field.
Take
so
a
I
guess.
can
Speculate.
I can
Because I
speculate.
agree with you, and I've often wondered this question. So now I want to hear what you have to say.
So if nobody fails high school, so the high school's graduation rate, I believe, is very high now compared to back in the day. And so if no one fails high school, then you can put in less effort and you will still graduate. So I think people are just putting in less and less effort. Actually, this morning, I was talking to one of our graduate students who is from Iraq. And I told him, oh, yeah, sometimes in high school, you can finish all your homework on the bus trip home. So it's like 30 minutes and you'll be done with all your homework for that day.
Yeah.
And he couldn't believe it. He was telling me, I was up till 2 a.m. doing homework every single day. This is insane.
Yeah.
So
It made it too easy on people.
Studying is one way to learn. And if you don't study, perhaps you're not going to learn.
Yeah.
So when we receive them in college, they don't have the basic mathematics, fundamental chemistry, physics. So it is very challenging.
How come professors aren't all getting together across the country and throwing a fit about secondary education and making sure that students are more rigorous in terms of math and science? And
we definitely complain, and we get a lot of pushback because they tell us, we want high graduation rates. Engineering is historically low. It depends where you are, but I don't know, maybe 50%, plus or minus a huge uncertainty margin, don't graduate with an engineering degree, even though they started in an engineering major. So there's a lot of push for us to get those numbers up. And so we complain and say, well, we're not going to graduate students that don't know the material.
Yeah.
So we say, they should have learned it, and been better prepared in high school.
Yeah, or take it, if you want to go down that road, take a year off and learn it and work for a year, save up some money, get some experience, and then come back to school.
Yeah.
I don't know, why do we go to college right after high school?
That is true.
This is crazy. People don't appreciate it. I think people have to work a little bit, make some money, actually pay for school and not, just take out loans that they're never going to pay back.
I think people of the Mormon faith will take, especially the males will take I believe it's 2 years off, and then they go and
they do their missions.
They do their mission, and in a way that I think is really good, especially those who go overseas.
Or like the Israelis join the army. There's all sorts of different methods to get people to do something real after high school and then appreciate college more a little bit more.
And we see that with our students, the ones that have come back after they've, I guess, for lack of a better term, experienced real life.
Yeah.
They know what they want to do. And they know why they want this degree, because they did not enjoy where they were before in life. And they're much more willing to put in a lot of time and effort.
Hard work. Yeah, that's what I don't like about all this conversation around, in the political sphere about paying for, debt forgiveness and paying for people's college. I feel like it's incentivizing the wrong behavior if you don't first fix the motivation problem and get people to the position where they really want to learn.
I think debt forgiveness is a very complicated, complex topic. And
Did I tread into deep waters here?
There are many different situations that students end up in. So I'm going to be careful not to make blanket statements. Because you can have situations where you go to a college and it was kind of a predatory college.
Yeah.
And you get tons of loans and they didn't really do anything.
Why are we allowing these loans to begin with, though? Isn't that something, isn't that then kind of criminal if the predatory loan companies, why are we letting them get away with this?
Why are we letting students take so much loan debt? is...
Or why are we letting these companies act in a way that's against everyone's best interest? Like we have laws against companies doing all sorts of predatory practices, right?
Yeah. Education is very expensive.
Another good question, why? Because it's like, I feel, do you ever you probably, I don't know you very well, but I'm probably willing to bet that you keep learning on your own time as well, that it's not just in a classroom setting that you're learning stuff.
Yeah, so it's kind of sad. I used to listen to a lot of music, and now I almost never listen to music because there's too much knowledge to learn. So
That's right.
I listen to a stupid number of podcasts. And
I feel like I'm talking to myself right now.
And one of the podcasts, I believe it was The Indicator or maybe Planet Money. They're very similar, I think by NPR. They actually talked about that exact question. I think it was The Indicator, why college education is so expensive.
Yeah.
So I'm just going to tell you, go look at the podcast. It is too much information to summarize here.
Yeah. Yeah. And there's just so much, there's so many good ways to self-educate these days too. Yeah, podcasts are one, even Khan Academy. Have you ever gone back on Khan Academy and oh God, I forgot this, I forgot linear algebra, time to go back to Khan Academy, that type of stuff?
I haven't been to Khan Academy.
Oh, it's good.
But I use Wikipedia a lot.
Yeah. Are you editing on Wikipedia also?
I do not have time to but I do donate actually to Wikipedia.
Me too. Every time they ask. Every single time they ask, because it's just you could not get a better deal on education. It's
ad-free, which I very much appreciate. And I understand if you aren't getting revenue from ads, then you must get revenue somewhere else. And as a student, I couldn't afford it. I can afford to donate a little bit nowadays.
Yeah, yeah. Okay, so back to nowadays. So you're teaching. Did we talk about some of the things that you're focusing on? So what do you focus on in terms of teaching the students? What are some of the areas that you like to teach the most?
So I like to teach what I research, which is a lot of non-proliferation, nuclear security. One of the things that has interested me a lot lately is nuclear material attractiveness. And this basically gets back to the beginning of our conversation with, if you have plutonium or even uranium or any material, how attractive is that to turn into a nuclear weapon if you're a proliferator? And is there quantifiable methods to reduce that attractiveness? So you can say, because there's different reactors, right? You said early on, we have basically production reactors that produce plutonium for nuclear weapons. And you put the plutonium or put the uranium in, irradiate it, and then push it out before it has too much irradiation to get that nice, sweet, sweet plutonium. Is there nuclear reactors and fuel forms that force that plutonium to be terrible? And how terrible does it have to be before it can't really be used in a weapon? And that's what I'm looking at a lot right now.
Which is the best so far? I mean, isn't a light water reactor pretty damn good because it's got to be totally sealed up, otherwise it's not working?
That is very nice. I'm probably going to offend every Canadian out there, but I do not appreciate reactors that can be refueled online.
Right, that's the problem. So CANDU is, RBMK is, anything that's that has a channel of some sort.
So a CANDU can be operated in that form.
Okay.
I don't want to say that the plutonium in it is all weapons grade. We did some calculations.
But I mean, that's why they created the CANDU. It was because the U.S. government needed Canada to participate in the war effort. We wanted them to create plutonium. They invented the CANDU. It's designed to make plutonium.
So light water reactors are nice because you seal them up, and so you only have to come in every once in a while when they're unsealed to make sure nothing's diverted.
Yeah. If it's diverted, it's probably got too much plutonium-240 in it.
So the main ways to create plutonium-240 is the amount of, time or irradiation. We call it burnup. So basically the number of fissions that occur in the fuel. The more time that it's in the reactor fissioning, the more the plutonium isotopes shift into less desirable weapons ones. So I like fuel that has very high burnup It turns out very high burn-up's good for economics. The less,
Yeah, win-win.
yeah, the less you have to refuel a reactor, the better. There are other interesting ways of trying to create plutonium-238. So this doesn't show up a whole lot in normal fuel. It's usually made from
235 counting all the way up?
Yes, instead of uranium-238 counting up.
Yeah.
So there's ways to promote that. You can do different things, put like americium in your fuel or neptunium. This is very much still on the research side, which I guess makes sense because I'm an academic.
Yeah.
But
yeah, are there ways to pollute the fuel in a way that doesn't affect the operation economics of the plant, but does encourage it ending up in a state that is proliferation resistant?
Yeah, so this is basically exactly the work we're doing.
Okay, cool. Well, so what's the best way? Give it away. Give us your secrets.
Give us secrets? It looks, based on our limited studies, so you're talking about something that would require many, many experts looking at different facets.
Sure. Give us your secrets.
But adding neptunium to the fuel looks very promising because neptunium captures a neutron, and then you have plutonium-238, which is terrible for a weapon.
And where do you get neptunium from?
Yeah, you get neptunium from recycling fuel. So you have to recycle fuel and then feed it back in.
More economic value from the old plants.
Yeah, and it actually turns out we do things with like burnable poisons. So when the fuel goes into the reactor, it has too much reactivity. So instead of adding lots and lots of boron in the coolant or control rods, you can actually add something to the fuel itself that absorbs neutrons. And then towards the end of the life, it has all burned out.
Cool.
So the nice thing with adding something like neptunium is it absorbs some neutrons early on and becomes plutonium-238, but that can then eventually lead on to more fissile material. So it actually acts as fuel towards the end.
Cool.
We still are doing like preliminary work, but a lot of these things look exciting. The main criticism we have with this is our fuel fabrication facilities are meant for just uranium right now. So you're talking a lot of infrastructure costs to do these new things. Another pushback that I've gotten is who cares about proliferation? All that matters is the economics of nuclear reactors.
Oh, well, come on. People care about proliferation too. Like, that's a big one.
I argue it's one of our grand challenges. And if you look at our Gen 4 reactors, they state, Gen 4 reactors will have the following capabilities and, improved economics. They say improved safety, improved waste management, and improved proliferation resistance. So I argue that it's one of the big four, but I'm just some young little professor, right? Why would anyone listen to me?
Okay, well, as we wrap up here, I would love to just kind of get your take on the future of nuclear energy at large. You've gotten to experience it through academia, you've gotten some experience abroad, you've got your niche of expertise. So I'd love to just kind of hear from your lens, where do things go from here?
Where does it go for nuclear energy from here on out? It's difficult to say. There's a lot of unknowns. So we say, one of the main competitors to nuclear power would be solar, and that is getting cheaper and better at a very rapid rate. So it'll be interesting to see if it continues that rate, and in 20 years, it is much, much better than it is now. And so then that would be a very good alternative to other energy sources. Natural gas is less polluting than, say, coal, and it is quite plentiful. So that seems to be the immediate switch. Nuclear energy has advantages that the U.S. energy market doesn't consider. So we just care about costs because, capitalism. And so you might ask, why is the UA building nuclear reactors? They have so much, oil, gas, it's so cheap. That's insane. It'd be super cheap for them to burn it. And so factors like the environment really doesn't have a monetary value. There isn't currently a carbon tax. So if there was a carbon tax, then that would relate, say, climate to finance. And then you might have something that says energy independence. Do you have to import all your energy sources? Like Japan. Japan doesn't have a lot of natural resources. And so if they have to import them, then that makes them vulnerable. So if you're importing, I think Germany imports quite a bit of oil from Russia. All of a sudden, this gives Russia power over Germany and says, I think you will behave in the following way. Otherwise, in the dead of winter, we'll just turn off the oil. So there are advantages to energy independence that we don't consider in the US a whole lot. If we have trouble I guess we produce a lot of oil now. But back in the day when we were relying heavily on Saudi Arabia, we would just go to war to make sure that there was a nice pipeline. So having your own supply gives you the freedom of not doing those types of actions. And then reliability. So if your hurricane shows up, nuclear plants just keep on producing electricity for those who need it during the hurricane. Certain other energy sources do not. And that is not captured in the financial market, I believe. So I think the future of energy could be very good if we consider all the other benefits that it produces that other sources don't.
Braden Goddard, thank you so much for your time and your insight.
Thank you for having me.